So on request, here are the answers to the true or false challenge in the CERDS C1 Foundations pack. This is great revision. These are the common mistakes that always lose marks on papers, so it's really important that you get clear in your head which ones of these are true and which ones are false. So, number 1 and number 2. Firstly, number 1, root A plus B is root A plus root B. That is completely false. Let's take a counterexample. So, root 4 plus 9 is root 13, which is some irrational number. We can't square root that and get a whole number. But root 4 plus root 9 is 2 plus 3, which is 5. Now, root 13 is definitely not root 25. So we know that that's false. In this case, it's a neat idea, but this 3 can't just come out of that squared bracket without something having happened to it. So we know that we can, when two surds are multiplied together, we can put them into one bracket. And if we expand that little bracket out in the side, we're going to get that. Now, we know that root 9 is 3. So 3 root A plus B can't equal root 3A plus root 3B. So that one is false as well. If you got either of those wrong, really worth going back over the surds information in the books or go and find some videos on it and get clear in your head what you can and can't do with surds. Okay, number 3 is false. And if you've committed this crime, you need to go and sit in a corner and think about what you've done. This square means write the bracket out twice. So let's do that. Root A plus root B, root A plus root B. Right, now we multiply those two brackets out. A times root A is A. Root A times root B is root AB. And we've got another one of those. Plus a B. So yes, we have got A and B, but we'd be missing this middle term here. So when we collect all that up together, it actually ends up being that. Now number 4 is true. This cubed means write the bracket out 3 times. So we've got root A times root A times root A. Now root A times root A is A, and we're still left with a root A on the end. 5 is false. We can't split apart this fraction like that. This is just so wrong. It's not happy. I'm sure you can think of a counterexample. We can, however, split apart a V. So if it had been A plus B over C, we could split that one apart. But this way around, the A shape, we can't. Number 6 is true. And this is a nice one. So what's actually happening here is that we're doing 1 divided by A over B. Now if you know about dividing fractions, what you're really doing here is keeping the 1 the same and multiplying by B over A. Well, now 1 times anything is itself, so B over A. This means that when we get a reciprocal, so A over B, and then a reciprocal indice rather, to the minus 1, what we can just do is flip it upside down. And then that saves us some working out some steps there. This one is false. This is really useful when it comes to rationalizing the denominator, where there is a surd plus, or minus indeed, something else. This plus and then a minus is a little bit like the difference of two squares in algebra. And when we multiply these two brackets out, we end up with an A plus a root AB minus a root AB, but also plus or rather minus a b. So we're missing a minus a b off here, but what is key about this is that these two middle terms cancel. So when we're trying to rationalise the bottom of a denominator with surds on it, using a method where we repeat the denominator, but with, if it's a minus sign in the middle, we repeat the same bracket with a plus sign in the middle, means we can get rid of any surd terms, and we've rationalised the denominator. In number 8, again, this is another one where if you've made this mistake, you need to go and sit in a corner and think about what you've done, because once again, this cubed means right out the bracket 3 times and doesn't mean just cube everything inside it. And I'm not going to bother multiplying these brackets out all the way because that's just going to take forever. But we do get an a cubed term, but then immediately we're going to get an a plus b, or rather an ab squared term, and then we're going to get a squared b terms and all sorts before we finally get a b cubed term. So we're just missing a whole stack of stuff in the middle here. Don't make that mistake, whatever you do. Okay, so this question 9 is actually true. And it's true in the same way that question 2 was false. So hopefully we've covered that. If you're not happy, go back to question 2, but think about it in the context of question 9. In number 10, we're false. Now, very cleverly, the minus has become a plus, and we're right, minus times a minus is a plus. But we're having to square everything in the bracket. So we're writing this bracket out twice. So we've got minus 3a times minus 3a. Now we've already discussed that the minus becomes a plus, so that's great. We've got an a squared term there. But we've got 3 times 3, which is 9. So don't make that mistake either. It's quite easy to do when you're thinking about so much and you've got the minus sign and you've thought about that, to forget to square the 3 as well. Okay, almost halfway there. This one is false. And what has happened is that this 4 is floated. And it happens. Sometimes numbers float. The best thing to do at this point is to use the sliding method. So we're going to put all of our numbers to the left and our algebraic terms to the right. So we've got no numbers on the top, so we're just going to use a 1. We've got a 4 on the bottom. And then we've got a cubed on the top and a 1 on the bottom there. So what we've actually got is 4 1/4 of a to the 3. Number 12 is true, because we have got root a times root a. Now, a square root is the inverse of a square. So what we're doing here is squaring the inverse of a square. So we're cancelling out that process. Whether we square and then square root, or square root and then square, we're just left with whatever's in the middle of all of that. So this one's happy, this is true. This one's true. Not always the case that you can do the same thing to the top and the bottom of a fraction. That's often a problem that people come across. But in this case, we can, when we've got a square root over a fraction, square root the top and square root the bottom. And if you don't believe me, try some examples and see for yourself. Number 14 is true. Because what we've got here is a times root b. That's all a root b is. And then we've got c times root b. So we can factor out the root b. And we're left with a plus c. (15) is false for the same reason that number 1 is false, except there's just a minus sign in the middle. So again, go back to number 1 if you're not sure why, and have a look at the counter example there. Unfortunately, 16 is also false, because I'm happy with the 2. We've got a square root of 4 times the square root of a to the 16, but this is a problem. If we convert this into index form for a minute, I'm happy with that bit. And I've got a to the 16 to the power of a half. Don't forget a square root is an index of a half. And then because we've got these over a bracket, we can multiply them together. So we've got 16 times a half, which is 8. What's actually happened here is that number's gotten square rooted as well, which isn't true. That's not what happens with indices. So this should be 2a to the 8, not 2a to the 4. This is true. We can always include extra brackets if we need them, and this is helpful because that means that is different, is the same as 3a squared, but of course if we then had a squared there, it means we're not including the 3. So that would be 3a to the 4, but if we have 3a squared, we're actually including it there, and we've got 3 squared a to the 4, which is 9a to the 4. But yeah, we can always include extra brackets if we need them. 18 is true as well. It's one of the laws of surds, that if you've got two things multiplied together, then you can split up the surd. And we use that all the time in cancelling surds. So if we have root 12, we can write that as root 4 times 3, just picking a factor pair. But that one's quite nice because we've got root 4, root 3, and then we can square root 4 to give us 2 root 3. Again, if you're not happy with this, go over the material in the textbooks or online to recap surds. Almost there. This one's true. We've got a V shape here, and that means that we can write each part of the numerator over the denominator and get this one. So yeah, this is true. 20 is also true. So we discussed before in one of the earlier problems, somewhere between 10 and 15, I think, that when we have the square or the cube root of a fraction, we can write that as the root of the top over the root of the bottom. Cube root of 27 is 3. And then here we've actually had the right thing happen to our index here, our 12. What we've got here is a to the 12 to the power of a third. Because in the same way that a square root gives a half, a cube root gives a third as an index. So we've got 12 times a third, which is 4. So we've got 3 over a to the 4. Now, this is on the bottom, so we can make that negative and write it on like all one line. So we've got a to the power of minus 4, which is happy. Okay, 21 is true. I'm going to start here, and I'm hopefully going to end up here. So, I'm going to deal with the minus sign first. I've got 1 over a to the 3 over 2. Right, now the 2 on the bottom is a half. So I've got the square root, but I've still got that 3 to worry about, so I'm just going to leave that as index form. And we've talked about the square root of a cubed before. That was problem 4. And we know that that's square root of a written out 3 times, which is a root a. So we've got 1 over a root a. Question 22, the last one then. This is actually false. And once again, our numbers have floated. So I would again use the sliding rule on this. I've got a 1 on the top and a 4 on the bottom. I've got no algebraic terms on the top, so I'm going to put a 1. And then I've got an a squared on the bottom. So I've actually got a quarter 1 over a to the squared, which is a to the minus 2. So just be careful about numbers floating. Just because you're not sure what to do doesn't mean that it naturally becomes a whole number. You've got to look at its position in terms of the rest of the fraction. And that's it. I hope those have cleared up some misconceptions for you. If they haven't, please make sure you ask questions, bring any questions to class, or do some extra revision to get those clear in your heads.